The heavy naphtha means it has, what are the parts of naphtha? Do you know? Okay, let me tell you. The parts of naphtha is basically paraffins and olefins. When there is a paraffin high, paraffin is more, it is called light naphtha. But when paraffin is less, it is called heavy naphtha. So these two are blended as the feed for the petrochemical products. So the more paraffin it is, the petrochemical will give you more ethylene and propylene. The less paraffin it is, it will give you the higher ones, C4s and others. So this two cut goes to the naphtha pool. The next cut, either it goes to a jet fuel or it's a kerosene. There are 3-4 cuts available at that plate. From the last cut, it receives a diesel oil, which gives a booster for the diesel cars or automobiles. And from the bottom, it goes to a vacuum distillation unit, VDU, which ultimately gives you the asphalt. What is the use of asphalt? As the bottommost product of a refinery.
Sir, carpeting
Highway
roads.
projects, in the construction of road mainly.
Very good, Tosif. Yeah. So asphalt is generally used as a construction of roads. That is a protective layer coating for the equipments. It is mainly used as a tar also for production of pure tar. Then asphalt is used for leak proofing, because it's a very high C. So it's has no direct calorific value because burning requires a huge amount of energy. So these are used as a protective layer only. From the bottom of the VDU, the residuum is taken, and after the delayed coker, there is a coker gas oil is available, which ultimately gives you the fuel oil. The fuel oil, again, it can be used in the automobile sector, or some gas are used in the furnace. And from the VDU, there is a gas oil heavy vacuum is taken out, which is again goes to a hydrocracker, and it's broke down to give you C4s and gasolines. The C4s, that is the isobutane, after alkylation, it gives you alkylate, which goes to the gasoline blending pool. So this is a very integrated and complex scene of a crude oil refining process. So the important parts are the equipments. First one is the distillation column, then the exchangers, the reboilers. Say for example, the vacuum distillation columns, the heat exchanger have a very typical type of design. Have you seen any cell and tube heat exchanger?
Yes, sir.
So cell and tube heat exchanger, in cell, where from the inlet generally enters, if it is a liquid,
Sir, mainly corrosive liquids are enter into the tube side, and
why?
for it's actually shell is very costly, and to
Very good.
protect
So
shell.
shells are protected. Tubes can be plugged if they are corroded. Okay. But the question is that not corrosive. If both the liquid, there are liquid, so you have to design a heat exchanger where from
Sir,
the inlet. Yeah.
Sir, I have one question. Can you
Sure.
please explain the delayed cooker? What is actually delayed cooker? I actually don't get it.
Good. What is coke?
Coke means
Coke means
Something
is a
cooking.
dry form of coal which is obtained at an anaerobic burning of coal
And every
so that the GCV, gross calorie value, remains at the highest position. So this thing helps to separate the residuum into coker gas oil and coker naphtha.
Sir, actually, delayed cooker is actually what kind of equipment, or how I actually separate all of the petroleum coke or cooker gas or cooker naphtha by using steam or something else?
Very good. So in okay, let me ask you one question. In distillation column, what is the driving force?
So, distillation from driving force.
Volatility difference.
Boiling difference.
Yes, yeah.
Okay. For delayed cooking or delayed cooker, the mainly there are two coke drums available which acts in a pit pop situation. One remain in line and one just waits to turn out to his position. The
I
thing that the vacuum residuum, yeah, I'm just telling something.
No, sir, you continue.
Okay. So what happens after it receives the feed from the what is that vacuum residuum? It goes from the bottom of the cooker by some preheater at around 30 to 40 psi. I'm not sure about the pressure. It goes inside the cooker where it is separated by the heating inside the cooker. So the beauty of the delayed cooker is it slowly gets heated. In the distillation column, the heating happens by the steam very fast. It has a single pass. But for cooker, it actually finds out some channels inside the cooks, and from that it actually gives you the gas or the separated gas, which again either goes and reflux to the first vessel or gets out at the fuel oil section, cooker naphtha. I'm trying to give you a picture. Just wait.
You are not audible.
No, I'm not saying anything. I'm just finding why they stop sharing. Yes, got it. I'm sharing a picture. Just wait. Yeah. So you can see the cooker inside. Here, how is that? Here, from the bottom, the feed goes, and it's called pineapple slicing method. Continuously on heating, upon heating, the gas and the high C's, means the C14, C15, almost becomes a typical cut coke, which ultimately gives you the part of coca naphtha. It's almost like naphtha, but it has a high, very high C percentage, C value. You can see the picture. There is not a very clear one, but there is a lot of controller is there. It actually cuts you. The coke bed is cut by layer. It's a difficult process. Who was asking this question?
Sir, I actually asked this question. Yes.
Okay, this is a process by which the whole higher C, means a C14 or C15, that becomes dried and made coca naphtha on a very high temperature on a slow basis to remove one of the most enemy of the naphtha is the moisture, and second one is the lighter products. So the lighter products goes outside of the delayed cooker. I am coming back to my original presentation so that you can see the process graph. For the delayed cooker, the C14 and C15, after hydrotreating and reforming at a very high temperature, it will give you a coca naphtha, but not more than 700 degrees centigrade, because above that the naphtha will try to break down itself. And the C13s and below, it will give you a off gas, which is again used as a fuel gas. But from the bottom, the solid cokes, it lies around C17 and higher. They are sent to the coking plants. If you visit DCPL, Durgapur Steel Plant, DSPL, there is a delayed coker unit. They used this technology to separate the higher carbons in the delayed coker unit. Okay, then. So basically they are using,
yes, sir.
So they are basically using the coal's property of being a coke in an anaerobic burning at a very high temperature, but with a slight delay, means a slow process.
Sir, is there any positive pressure in the delayed cooker?
Yes, delayed cooker, there is a positive pressure, but it remains almost like atmospheric. Tell me why?
Just asking, sir, because in previous the vacuum distillation,
yeah,
vacuum distillation is negative pressure, but so delayed pressure may be negative or positive. So that's why I asked this.
Because for in a refinery or petroleum, whatever things move, it moves from plus pressure to minus pressure. Means there is a pressure gradient. For this vacuum distillation, the vacuum residuum reach to delayed cooker. If you reduce further pressure, if you get it further vacuum, there will be true problem. What will be the problem for a vacuum vessel? What could be a problem for vacuum to create a vacuum inside a vessel?
Maybe break down the column also.
Exactly, it will buckle up. It will buckle down because metals are very good, having very high much tensile strength, and cement are having very high compressive strength. So opposites are non-benefiting. For a delayed cooker or metallic unit, if you make it further vacuum, it will buckle. That's why there is a pump in a vacuum residuum system, which is basically a long capacity or long rated power gear pump to hold this high amount of C's, or there is a conveyor belt so that the entire system remains not in the pressure gradient, and then the delayed coker operates at very atmospheric range of temperature. But where there is a temperature less region like North Europe and North America, the delayed coker units are operated at vacuum, because in their area the atmospheric pressure remains itself higher because of the cold air temperature. So that helps. So this is the
Hello, excuse
refinery.
me, sir.
Yeah, sure.
Sir, I am having a question.
Yeah.
Sir, we know that we use one form of energy to obtain another. Like we know how a distillation column runs. Basically, we use majority use coal to heat up the distillation column, right? And now electric distillation columns have also arrived. But previously we were using coal, and right now also many you are using coal to heat up the distillation column. So we are using one energy to generate another form of energy giving substance like petrol, diesel, jet fuel, etc. But sir, when I want to know that when was the when was how we got that first crude oil distillated, like that we have to use distillation column for this, means how the first crude got distilled and we got fraction, that we have to use coal to generate
Mhm.
petrol.
No, actually, if you have missed the first two slides, the first distilleries or coal refining for the crude oil refining process, they used to heat up the entire thing by fuel wood. They used to burn woods to get a temperature. But the problem with the wood, first is the removal of ash, which has to be very quick. Second is the required amount of temperature. For coal, the GCV is much higher than the wood, because woods are having moisture inside them. So with the less GCV, you cannot reach further temperature. That's why the crude oil distilleries of the ancient times, in the ancient means 1850s or 70s, the distillation was not so much separated cuts. They used to have a very inferior type of coal from the bottom of the vacuum distillation unit.
Okay, sir.
And
And what's the MOC
yeah,
for distillation column?
presently or previous one?
No, no, both. Presently and previous both.
Presently, for the distillation column, there is a alloy used having stainless steel,
Hmm?
some amount of chromium and molybdenum, and a LTCS. That is a low thermal carbon. These are made prepared to form the atmospheric distillation column. For vacuum distillation column, it is always metal with less amount of carbon to make it a vacuum proof. But for earlier days, I'm not sure, because if the heating is not there, how they can prepare the alloy? So maybe they used to have cast iron for their distilleries. I'm not very sure on that.
Sir, I might sound silly, but I want to ask that can ceramic be also used in the distillation column for MOC?
What would be the major problem if we use ceramic for the registration column?
Um,
What are the
when we will
properties of ceramic?
when we will heat it, it would get some cracks in that.
And why that? Why is that? Because are ceramics as a good conductivity like metals?
No.
That's why on each tray in the distillation column, there will be local heating. and there will be that is called temperature hotspot. If
Yeah.
temperature hotspot no, generates inside a ceramic column, it will, yes, you are correct, it will create a lot of cracks on that.
Sir,
Yes, Nirupar, you want to tell
I'm not,
something?
I'm not you are not audible to me because of someone else.
Yes, Nipun, you want to something? Just 1 second, Tasif. Okay.
I'm
So,
asking modification in ceramic, like we use alloys. Something can be done with ceramic to withstand some properties.
I'm not sure on that, Tasif,
Because
because
sir,
that is,
we also
yeah,
know that one metal can't withstand at this much high temperature. That's why we are using alloys. Just like
yes.
that, because I have read somewhere some people are trying ceramic material somewhere. I had read.
Okay, maybe research is going on because, yes, the more and more we are using crude oil refineries, some more carts are every year discovered. So, for making a more cart, either you want to increase the columns level or distribute the column into 2 or 3 columns with a very high amount of temperature. To withstand that property, maybe one day ceramic will be mixed with that after the pilot test is over and some no, proofs are we have obtained. Yes, maybe.
Okay, sir. Thank you.
You're welcome, always. So what we get out from the what we get no, from the refining process, the blue lines. First is the LPG and butanes, but still they are of earlier Indian grade or European grade like Euro 2 or Euro 3. Then jet fuel, kerosene, some oils like diesel oil, fuel oil, jet oil, asphalt, coke, and naphtha.